Leetcode 54 spiral matrix. It's a medium type problem, and I would say that it's correctly classified. And even though we can write the final optimal solution very efficiently, at least using Python, here on the right side, we can do it in a couple lines of code. It still requires us at least to understand that there are multiple steps, and anything that is multi-step, in my words, it's at least a medium type problem. So I would say it's a very good medium problem, and it requires you to understand, of course, matrix operations, indexing on matrices, and in this case, we will also do transformations on matrices, and to be precise, rotations. So we will talk about rotations, indexing, and so on. So here is the description. Description is very short, but it requires us, of course, to have some previous knowledge about matrices to even be able to attempt to solve it. So we have an m times n. M is number of rows. Always first is number of rows and then number of columns. And a lot of times they swap those letters, so don't pay attention to letters. Remember that first are the rows, then are the columns. And the matrix is called matrix, and in Python is a list of lists of ints. Yeah, and because it's m times n, yeah, it doesn't need to be square. Yeah, it can be just like a rectangular matrix. The number of rows does not necessarily equal the number of columns, even though in the first example we have a square matrix, but it doesn't need to be the case. And the task is to return all the elements of the matrix in spiral order. Yeah, so we can create or we have to create an additional structure, a list. Yeah, the output is list of ints, the input is 2D, output is 1D, and we will have to gather the list of elements, not indices, the elements, the values themselves, that are gathered from the original 2D matrix in a spiral way. Yeah, and here is an additional explanation. They don't explain in the problem itself what do they mean by spiral order, but they explain it visually here below. So the first example is as following. We go the first row, we go the same order as normally, or as they arrive in our input data structure, and then we move to the column, then we go from top to bottom, and then we reverse the order. We go from right to left. Yeah, so first we go left to right, top to bottom, then right to left, and again bottom top, and here starts again the same. And we can continue this depending on how big is this matrix. Yeah, so the last step in this particular example is left to right, as it was in the first row, but of course the matrix can be bigger, and it can have we could continue with this process of going first left right, then top bottom, and so on, a couple more steps. And the input is correctly specified, so a lot of times they have discrepancies between the input described here, for examples, and the input which is really expected in the code. In this case, it's correctly specified. So this is just a list of lists in Python, and it represents the following matrix. And of course, the output is a single list where we just gather those numbers or the elements of the input matrix in the following way, this spiral order. Yeah, so 1 2 3 6 9, 1 2 3 6 9, 8 7 8 7 4 5, and so on. Yeah, and here is the second example, which is a bit more complicated. As I said, we don't have to necessarily expect, or we shouldn't expect at all, that the input matrix will be square. And the number of columns and the number of rows can differ, as it is the case here in the second example, but the general strategy stays the same. Yeah, so we go first left to right, then top to bottom, then right to left, and so on. So it stays the same. Let's now think about that problem in a greater detail before we start writing any code, and also discuss all the possible rotations. Maybe not all the possible, but the most common for those kinds of problems. Let's copy this as well. And we can rearrange it graphically to be more matrix-like. Yes, I'm not changing anything, I'm just making it more like matrix. Yeah, and there are a couple transformations that we should discuss on matrices, and which we should understand and know how to implement in Python. So the easiest one is transpose. Transpose, which basically means swap elements on index on the row I, on the ith row and jth column with the jth row and ith column. Yeah, so we can write it down. Well, ith j with ji. Yeah, like this. And let's make it smaller since right now we are getting out of screen. And the second is clockwise rotation. And of course it can be any number of degrees, but usually we talk about 90 degrees clockwise rotation. And there is counterclockwise rotation, which we will use right now. Yeah, and basically both clockwise and counterclockwise rotation consists of two steps. First step being the transposition, and second step being something else. And for clockwise rotation, it's transpose and reverse order of each row, within the row. And for counterclockwise, it is transpose and reverse order of rows within the matrix. Not within each row, but the rows themselves are reversed. So the ones that were at the bottom go to the top, and the ones that were at the top go to the bottom in the matrix. Basically, those are the most common when it comes to those kind of problems. And you should, first of all, understand what do they do. So when you have such an example, you should be able to see it, at least in your brain, and also be able to like show it on a piece of paper or here in Excalibur. What does it do, given what given transformation does to following input, and second of all, how to implement it in the most efficient way in Python or any other language. If you are using some other language, of course, it doesn't really matter what kind of syntax you use. The most important thing is understanding what's going on. Let's do all three examples, or all three transformation on the following example, just to see, first of all, what do they really do, and then how to use them to solve our spiral order. Yeah, because those are the steps, as I already hinted. Exactly the counterclockwise rotation, to be precise, will be used to achieve a spiral order. Yeah, but first, let's do those. And maybe you can just copy. Yeah, and let's first have the transpose operation. And what do? We leave the elements on the diagonal the way they are, and we swap the ones from two different sides of the diagonal with each other. Yeah, so 2 and 4 get swapped, and 3 and 7. Yeah, so he gets 3, 3, and here 7, and 8 and 6. That's it. And the diagonal stays the same. There's a transpose operation. Now, clockwise is transpose plus reversing order in each row. Yeah. So let's copy that. We can have here clockwise 90 and counterclockwise 90, which will end up with reversing. So 7 and 1. Yeah, we have to reverse the order in each row. 8 and 2, 9 and 3. Yeah, and here we reverse the order of the rows themselves. So this one goes to the top, and the one from the top goes to the bottom, and that's it. And that's it. Move. And we have counterclockwise rotation. And as you can see, let's copy the output. Something gets similar. Yeah, you can see 369, 369, but not completely. That's because we have to continue counterclockwise rotation up until there are no more rows. Yeah, so let's keep it here, and let's now write the algorithm for the spiral order. While there are still rows, pop the first row and add it to the result. Rotate counterclockwise, CC Dublin, the rest, and continue like this. Yeah, so from here we will go here, and we should achieve the following result. But let's maybe make it a bit bigger. I will remove it, add it in a second, so it's more visible. Yeah. So the algorithm to achieve the spiral order will rely on the following rotation. And let's put it like this inside. And let me add it once again. Like that. Okay, so let's copy it here. And we'll try to build a result so that we'll have exactly the same thing. Yeah, so the first step is to pop the first row. The result is empty at the very beginning. And then we pop the first row, meaning we remove that part. And we add it here. Let's then rotate it in the following fashion, counterclockwise, meaning in this direction. Yeah. So here will be our rotation, but don't know if it's that visible. Maybe let's just do it here, but we can show that basically this part we will mark it as green, and this part we will mark it as blue. Yeah. So how this rotation works, this row will become a column. Yeah. And we can copy it. Let's copy it here. Or maybe it will even be easier to just write it down from scratch. Yeah, so we have 6 and 9. Then we have this column becomes our top row. Then we have 5 and 8. From here, oops, sorry, 5 and 8, and then 4 and 7. And then 4 and 7, and close. Let's make it bigger, like this, and let's grow it a bit, like this. And what happened here is our counterclockwise 90 degrees rotation. So as you can see, the green, where is the green? The green part is here, and the blue part is here. Yeah, that's basically how you can visualize this rotation. Yeah, and then we of course continue. We pop the first row, so our result grows, meaning we remove this part, 6 and 9, and then we rotate again from here, and we get 8, 7, and 5, 4. 7, 5, 4, yeah. And that's of course still the list of lists. Like this. Make it bigger. Okay, and then what we do, we remove this part. 8, 7. And you can compare the result that we arrived at with the result that we copied from here, from the problem itself, is that it's exactly the same. 1, 1, 2, 2, 3, 3, 6, 6, 9, 9, 8, 8, 7, 7, and 4 and 5, which we, of course, after rotating this, what we will get. Let's just do it for the sake of being complete. Copy it like this. And we will have right now 4 and 5. Yeah, and the 4 will be the next row that we pop. And 5, of course, is the last row, so we have to add it after the rotation. Let's make it like this. And the next one is, of course, 4. And then the last one is 5, meaning that we have reproduced successfully everything. Yeah, but that's it. So once you understand how it works, once you can visualize it, writing the code shouldn't be an issue. So let's first create a result list where we will store our results, and then we will return them by the end. And while we still have rows in the matrix, we will be popping our rows from the front matrix pop there, and extending the result by the row, and then we do the counterclockwise rotation, which we can do in a couple ways. We can do separately, first transpose, then reversed, or we can do it all together in one list comprehension. So matrix will be overwritten by row for row in zip. Yeah, and we can unpack the matrix, so which will get each element, and each element of this matrix is, of course, an inner list, which is our row. Yeah, so for each row, we'll be zipping elements of each row together one by one, which will result in an transposed matrix. Yeah, so zip plus unpacking gives us transpose, and then we can cast it again to a list and reverse. Yeah, so we said that reversing the order of rows on a transposed matrix gives us counterclockwise 90 rotation. Let's see, that works. That's correct. And now let's submit. And we beat 100% of the people, but of course, most of the solutions use the same logic. Since once you crack down what's happening here, you should have more or less similar code, but of course, this can be also split to two separate operations.